This is Mr. Craig, and the purpose of this video is to help you name acids. One thing I want you to recognize is if you're given a chemical formula that you recognize that it is an acid because it starts with hydrogen. There are two types of acids that you should be very familiar with. Acids that contain oxygen and acids that do not contain oxygen. The first type of acid that we're going to talk about in this video is the acids that do not contain oxygen. If an acid doesn't contain oxygen, we must write the prefix hydro in front of the acid name. Since it has no oxygen, you are looking at an element, a non-metallic element that is connected with a hydrogen. And so typically what we'll do is, if I look at, say, something like hydrochloric or hydrogen chloride that's dissolved in water, I'm going to actually drop the IDE ending in this, and I'm going to add ic. So in this case here, even though it says hydrogen chloride, I'm going to call HCl, I'm going to call it hydrochloric acid. So the hydro up front indicates that we have no oxygen in the compound. The ic ending is the appropriate ending because we have an element. So if you have an INE, a gen, any one of those things, we're going to put ic at the end. Let's look at some examples. If I have HF, well, F is fluorine. So we're going to drop the ene and put ic, so we'll have fluoric. But since there's no oxygen, we're going to call this hydrofluoric acid. Looking at H2S. Now the reason why we have a 2 here is because acids are considered to be ionic in nature. So the 2 here is here because sulfur has a -2 charge. So we still have to be aware of charges when we name these things. Alright, so if we look at sulfur, we would drop the UR and put ic. So some might call it sulfic acid, but it's really called sulfuric acid. So really we're not dropping any syllables with the element sulfur. Now also you'll notice that there is no oxygen within the compound, so we have to put the prefix hydro at the beginning. So H2S is called hydrosulfuric acid. If an anion or the nonmetal, which is an anion, does contain oxygen, you're looking at a polyatomic ion. And if you're looking at a polyatomic ion and it ends in ATE, like nitrate, iodate, chromate, sulfate, carbonate, phosphate, all those polyatomics that end in ATE, you are going to substitute ATE and put ic. So if I have sulfate ions and I go ahead and put hydrogen at the beginning of this sulfate, then I better have H2, again, because we're balancing out charges. And again, what we're going to do is more for the way that it sounds. Yes, if you drop the ATE and put ic in there and called it sulfic acid, we're going to be okay with that. However, as you hear these names over and over and over again, you're going to know that sulfuric is more appropriate than sulfic. But you should never be counted off if you called H2SO4 sulfic. Also, one thing I want you to recognize, no hydro is at the beginning of this acid name because we have oxygen. Since oxygen is present, no hydro. Hydro has nothing to do with the presence of hydrogen because all acids, again, have hydrogen contained within them. Let's look at some examples. We will look at HNO3. Well, if you cover up the hydrogen and you're left with just the NO3, what polyatomic do you have? Well, you have nitrate. And again, what we're going to do is drop the ATE ending and add ic. So you should have nitric acid. Again, no hydro. You have oxygen, no hydro. If that oxygen were not there, okay, we'd have to balance a lot of things here. But if that oxygen was not present in the compound, then we would stick the hydro. Let's look at another example. H3PO4. Again, covering up the H3, what polyatomic do you have? Phosphate. So you would exchange the 8 for an ic sounding, except this one's just like sulfur, where we're actually going to have the or in here. So we actually look at phosphoric acid. Now if you call this phosphoric acid, again, no harm, no foul, you're going to be alright. But as we hear this over and over and over again, you're going to recognize that phosphoric acid sounds better than phosphoric acid. And phosphoric really is the correct name for it. Alright. When an anion or a polyatomic ends in ITE, then we're going to drop the ITE ending and add OUS. Now, when you have an ITE ending, that typically means that one or more oxygens have been removed from the polyatomic. So, for example, sulfate is SO4 with a -2. If I remove one oxygen, now I have sulfite. Don't get hung up on the charge. Charge always remains the same. We'll talk about why the charge remains a -2 later on in the year when we start talking about oxidation numbers. So we have sulfite. So since we have sulfite, we're going to drop the ITE ending and add OUS instead of ic. Ic indicates that we have our full polyatomic ion. So we would call this, if you want to call it sulfus acid, that's fine, but sulfurous sounds better. So H2SO3. Let's do some examples. Again, recognizing your 10 polyatomic ions. So this is one less oxygen than nitrate. So NO2 is called nitrite. So you would call this nitrous acid. Don't forget to add the word acid to the end of this. Just calling it nitrous isn't the same thing as nitrous acid. H3PO3, again, make sure you know your polyatomics because PO4 is phosphate with a -3 charge. That's why we have 3 hydrogens here. So the name of this acid would be called phosphorus acid. Again, dropping the ITE and adding OUS. Let's look at a few more examples. HNO. Hopefully you recognize that 2 oxygens have been removed from the polyatomic nitrate ion. So it still has an ITE ending. So we're going to drop the ITE input, us, but also since 2 oxygens have been removed, we also have what's called hypo. So in this case, we have hypo nitrous acid. Hypo and hydro, 2 different things. Hydro means no oxygen. We obviously have oxygen here. Hypo means that I've taken 2 oxygens away from the original polyatomic that had an ATE ending. Charges again remain the same. If I look at H2SO2, sulfate, SO4, is one of the 10 polyatomics that you're supposed to memorize. So I've removed 2 oxygens. So I have hyposulfurous acid. Again, hypo, us, means that I actually have a polyatomic that is called hypoite. Okay, let me give you some more examples here. We've already done the HF. Now, since this video has a pause feature on it, I'm going to show you the name here, and then I would actually, once you see the name, go ahead and I'm going to show the answer. Pause it before I give you the answer, because I don't want this video to just have a long pause. So attempt to name this, but again, what I'm going to do is try to give you a 2 or 3 second lag to hit the pause button, try to name it. And I'll explain as we go on here. HF again was one of our examples. We have no oxygen in this, so you better show a hydro or write hydro in this. Fluorine, drop the ene and put ic, so we should have hydrochloric acid. And that's what we have on there. Okay, let's look at the next example. HCl, probably one of the most common acids that you could be aware of or familiar with. Again, we have chlorine, so drop the ine and add ic, and you have hydro, because there's no oxygen, hydrochloric acid. Alright, try to name this one on your own. I hope you said that we had a polyatomic ClO3, which is chlorate. So since it's chlorate, we're going to drop the ATE ending and call it chloric acid. No hydro, because we have oxygens. Okay, go ahead and try to name this one. Hopefully you recognize that we had one of our polyatomics, acetate. So again, drop the ATE ending and put ic, and you have acetic, or yeah, let's just call it acetic acid, or vinegar. HI, no oxygens present. Go ahead and try to name it. Hopefully you called this hydroiodic acid, because again, iodine and the hydro tells us that we have no oxygen. Okay, try to name H2CrO3. Hopefully you recognize that we have one less oxygen than the polyatomic chromate. So since we have not chromate, but we have chromite, this should be chromous acid. Chromous acid. And again, we won't count off for spelling, so try to get it as close as you can. Alright, take a look at this one, try to name it. Hopefully you recognize that we have one less oxygen than the IO3 polyatomic, which is known as iodate. So we have iodite. So we're going to drop the ITE and make that iodous acid. H2SO4, we have one of our 10 polyatomics. So SO4 is sulfate. Drop the ATE and make it sulfuric acid. Go ahead and try to name this. No oxygen, and we have nitrogen, so drop the O-gen and add ic. So you have no oxygen, so it should be hydronitric acid. Here's an interesting one. Se, selenium. So that's an element. So drop the em and put ic, and you have no oxygen, so hydroselenic acid. Go ahead and take a look at this one. Try to answer it. Hopefully you recognize that we have a polyatomic here, IO, which is 2 oxygens less than iodate, IO3. So we have a hypoiodite. So hypoiodite. So drop the ite and add OUS. So we should have hypoiodous acid. Hypoiodous acid. Okay, take a look at this one, try to name it. Hopefully you recognize that we do have one of our 10 polyatomics, carbonate. Drop the ATE, call it carbonic acid. It's a very weak acid that's in your drinking water. Carbonic acid. We'll talk about how carbonic acid's formed later. H2SO2, try to name that. Hopefully you recognize that we have 2 less oxygens than our sulfate polyatomic ion. So this SO2 all by itself is called hyposulfite. So this acid would be hyposulfurous acid. Okay, HNO. Try to name this. Okay, hopefully you recognize that we have a polyatomic and we have 2 less oxygens than our NO3 polyatomic, nitrate. So this is hyponitrite. Therefore we would call this hyponitric nitrous acid. Go ahead and try to name H2S. You recognize there's absolutely no oxygens present, so we have to have a hydro at the beginning of this. And since it's sulfur, then we're going to drop the... Actually, we're not going to drop anything on this and just call it hydrosulfuric acid. Sulfur and phosphorus, really strange, but that's okay. You'll get used to it. Hyposulfuric acid. The good news is those are the only two that we have to worry about. Alright, try to name HClO2. Hopefully you recognize that we have ClO2, which is one less oxygen than ClO3, which is chlorate. So we have chlorite, and since we have an acid, we're going to call it chlorite. We're going to call it chlorous acid. H2SO3. Go ahead and try to name that. Hopefully you recognize that we have one less oxygen than the sulfate. So we actually are looking at a sulfite ion. So call it sulfurous acid. Go ahead and try to name H2CrO4. Hopefully you recognize that we have one of our 10 polyatomics, chromate. So drop the ATE ending, call it chromic acid. Try to name H3PO3. Hopefully you recognize that we have one less oxygen than our PO4 counterpart, which is phosphate, so we're actually looking at phosphite. So we'll call this phosphorus acid. HNO2, try to name that. We have one less oxygen than our nitrate, so we have nitrite, so this should be nitrous acid. Okay, try to name HBr. We have no oxygen in this compound. Also, bromate, BrO4, is not one of our polyatomics, so don't get creative and call this bromic acid, but call it hydrobromic acid. H2CO, try to name that one. Hopefully you recognize that this is a few oxygens less than our CO3 carbonate, so we're looking at the polyatomic actually hypocarbonite, so we're going to call this hypocarbonous acid. HiO4, try to name that. Okay, this is our first example of having an acid with more oxygen than the polyatomic, and we have per iodate. Well, the good news is, since we have an oxygen, we're not going to use hydro, but we will keep the per intact. So we should call this, and it ends in ATE, so we're going to call it per-iotic acid. Go ahead and try to name H2CrO2. Okay. Hopefully you recognize that we have a polyatomic that has two less oxygens than chromate. So we're looking at the polyatomic hypochromite. So this would be hypochromous acid. Go ahead and try to name H2CO4. Hopefully you recognize that we have one more oxygen than the carbonate ion. So we're looking at percarbonate, but we're going to drop the ATE ending and put ic. So percarbonic acid. HNO3, Try to name that one. We have nitrate ion, so drop the AT and put IC for nitric acid. Alright, I'm going to cut this short here since this will be the last example. I know there's 10 more examples. I'll let you go to the website and try it out. I don't want this video to be too long. But I highly encourage you to try it. It's in the section where we're naming compounds. But let's go ahead and actually you can see the address right up here on top. So go ahead and type that address in, and you can take the last 10. The order is the same, so if you don't want to have to type the answers in, you can always click on what I've been doing here on just show the answer. So this last one, try to name it real quick, and this will be the end of the video for acids and bases. No oxygen, so we have phosphorus, and so we're going to call this Hydrochloric Acid. I hope this video has helped. If you have any questions, by all means, email me or contact me.